Hi, welcome to the video. In this video, we're going to be solving the problem stairs climbing. So let us get started. The problem statement is as follows. You can climb either one or two stairs with one step or two steps. So every time you can either climb one step or two steps. So how many different ways can you climb n stairs? So let's say we're trying to climb 3 stairs. We can either climb one stair, then one stair, then one stair, or we can climb one stair, then 2 stairs, or we can climb 2 stairs, then one stair, for a total number of 3 different ways of climbing the 3 stairs. So this problem asks for the general case. How many different ways can we climb the n stairs? So a very naive solution that we might get at the beginning is let f of n be the number of different ways to climb n stairs. So we ask ourselves the question, how did I reach to the nth stair? So right now, if I've just reached the nth stair, how did I reach here? Well, there's 2 cases. The first case was that I was on the n-2th stair and then I climbed 2 steps, or I might have been at the n-1th stair and then I climbed 1 step. So for the first case, how many ways could I have reached the n-2th stair? Well, we know by the definition of f of n, it's f of n-2. The number of ways I could have reached the n-2th stair is f of n-2. What about for 2, the number of ways to reach the n-1th stair? It is f of n-1, again using the definition of f of n. It's the number of different ways to climb n stairs. So f of n-1 is the number of different ways to climb n-1 stairs. So, in other words, the number of ways to climb n stairs is the number of ways to reach to climb to the n-2th stair. Then I take 2 steps, so that's a plus, the number of ways to go until the n-1th stair, and then I climb 1 step, which is f of n-1. Or f of n is equal to f of n-1 plus f of n-2. So an idea that we should automatically get is to use recursion to solve this problem. The base cases here would be f of 1 is 1 because there's only one way to climb 1 step, which is to climb 1 step. And the second base case is f of 2, which is the number of ways to climb 2 steps. It's either we go 1, 1, or 2 right away. So there's 2 different ways of climbing 2 steps. So let us have a look at how a recursive code would look like. So this is how a recursive code would look like in C++. So we're including IOStream using namespace standard, and we're defining a function called stairs, which should give us the solution. And it takes an argument of n, which is the number we're trying to solve for. So we check. If n equal to 1, then return 1, because that's the first base case. If n is 2, then we return 2, because that's the second base case. Finally, we return stairs n-1 plus stairs n-2 recursively, like we defined in the previous problem. And then in the main function, we just call stairs on any input. So let's say on 10. Now this code theoretically should work pretty well, and it should give you the correct answer. However, what happens when you go for a large input? When I tested my code on stairs of 45, my code took on my computer, it took around 20 seconds to execute. Now, that's a lot of time for a program to finish on a very small input. What happens for large input? For example, n equals 100. When I tested it on my computer, I left it for 1 hour and it still didn't terminate, and I didn't know why. Well, the why is because the program takes an exponential time. Let us look at the recursive calls that are being done. We start here. Here's the code for reference if you want to see it. So we start at f of n, right? And we're calling f of n minus 1 and f of n minus 2. Then f of n minus 1 is calling f of n minus 2 and f of n minus 3. But hey, wait a minute, we already called f of n minus 2, and here f of n minus 2 is again being called. And this one's essentially going to have a bigger tree, which is the same as this tree, and then these ones are going to have bigger trees, and again here we've called f of n minus 3, and this it's called repeatedly here. So in other words, every time the amount of work that we're doing is more than what we need. Instead of only calling the number of functions that we need, we're calling a huge tree that contributes to an exponential time in our running time. So the running time of this program ends up being exponential. We're not going to go into too much details of how we reach the type bound, which is phi of power n. You don't really need to know this, or phi is the golden ratio, but this program ends up taking a lot of time to run, exponential, and hence why when I put n equals 100 on my program on my computer, it took more than 1 hour and it never closed. So what is the solution for this? And you might have guessed it, it's dynamic programming. So the solution here for using dynamic programming is, let's start by first defining an empty array of size n, and we'll call it S. So S should store the results of this problem. So for example, S10 should store the number of different ways to climb 10 stairs. S11 should store the number of different ways to store 11 stairs. Now, we first do the base cases, which are S1 equals 1. So the number of ways to climb 1 stair is 1. And S2, the number of ways to climb 2 stairs is 2. Again, these are basically the base cases. Then, instead of calling the function recursively, we do a loop. So we go for I equals 3 to n. Si is equal to si minus 1 plus si minus 2. So we're saying that the number of ways to climb I steps is si minus 1 plus si minus 2. So when I equals 3 here, this would be s2 plus s1, and we already know what s2 and s1 here is. Now we've computed s3. Now this goes to I equal 4. So S4 is S3 plus S2, and then we also know what S2 is, and we know what S3 is from the previous iteration, and so we slowly built this dynamic programming array to include the solutions to our subproblems. And finally, when we're done with this loop, we return the number of ways to climb n stairs, S of n. Now this solution should take linear time because we're only doing one loop from 3 to n, so it should take O of n time, which is much better than the exponential time that the recursive algorithm took. Now let's look at the solution here, which uses dynamic programming and the code is in C++. So again, we include IOStream using namespace standard. We let int n equal 45, that's the input I want to try. Then I do a new array with size n plus 1. Make sure it's n plus 1 because since C++ starts counting at the zeros index, so I want to be able to count up to n, so I need to have n plus 1 elements in it. I let s1 equal 1, s2 equal 2, and then I do a loop from I equals 3 to n, and si equal si minus 1 plus si minus 2, and I iterate every time plus I. So at the end, I should see out as n, and I should have the solution, the answer as n. When I ran this code on my computer, it took 31 milliseconds, which is much better than 19 seconds if you can see the difference between the two. So, in other words, we've taken the solution from going to an exponential recursive solution, and we put it down into a linear dynamic programming solution that uses linear time to solve the problem. Of course, this doesn't have to stop at only one step or two steps. So the next step for you to try is to try and solve this problem, but instead of only one step or two steps at a time, why not try one step, two steps, or three steps at a time? So you should be able to come up with after thinking for a while, you should be able to come up with a recursive solution for instead of one step or two steps, you can either go one step, two steps, or three steps. And then you should also take it from the recursive solution and figure out what the dynamic programming solution is. Take the dynamic programming solution. It should also run in linear time. Make sure you do this problem before you move on to the next video, which we'll be discussing again another dynamic programming question, but it's very crucial that you understand this example and you also solve the problem I just solved. So in other words, you need to solve the same exact problem we solved, but how many different ways can you climb n steps? But instead of climbing only one step or two steps at a time, you can also climb 3 steps at a time. And yeah, that's basically about it. Make sure you solve that problem. Post your code in the question and answers section, and I'm gonna personally review it for you, and I'll let you know if there's any problems in it. But hopefully it should, after watching this video a couple of times, it should be very straightforward how you should approach the problem. It's very similar to how we approach this problem. And yeah, I'll see you in the next video where we will be covering another dynamic programming question.